Now we are starting with topic Thomson model. Thomson stated that atom is uniform sphere of positive charge with negatively charged electron emitted. So the Thomson's observation are: most of a particle pass through the foil undeflected or deflected by very small angles like less than 1 degree. Few particles were deflected through angles as large as 90 degree. Very few particles, 1 in 20,000, bounce back or ejected through an angle almost equal to 180 degree. Angle of deflection increase with increase in atomic number. So the conclusion of this Thomson model is, since most of A particles pass through the foil undeflected, therefore there must be large empty space present in the atom. A particles are positively charged and having considerable mass could be deflected by only some heavy positively charged center by repulsion. Rutherford named this positively charged heavy center as nucleus. Okay. Since very few A particles were thrown back, therefore the size of nucleus should be very small and it should be rigid because A particles can recoil back and if it undergoes direct conclusion with the heavy positively charged center. So now we will start with Rutherford's model. Okay, on the basis of scattering experiment, Rutherford proposed an atomic model or nuclear atomic model or nuclear model of atoms. So the radius of nucleus is radius of nucleus is the order of 10 raised to minus 5 meter and radius of atom is order of 10 raised to minus 10 meter. So R is equal to R0 A raised to 3. A is mass number is equal to number of protons plus number of neutrons. R raised to 0 is constant is equal to 1.2 into 10 raised to minus 13 centimeter. Okay. So the next topic is failure of Rutherford's model. Okay. According to Maxwell wave theory, an accelerated charged particle like electron revolving in the field of another charged particles like nucleus loses energy in the form of electromagnetic radiation, and if this happens, then orbit of the revolving electron should keep on decreasing and unlimitedly electrons should fall into the nucleus and atom should collapse. But this does not happen actually. Rutherford model did not give any idea about electronic arrangement of an atom, and since he did not mention specific energy level, he could not explain the discontinuous atomic hydrogen spectrum. So now we are starting with topic atomic number and mass number. So I will tell you how you are going to identify the atomic number of an element. When total number of proton present in the nucleus and total number of electron present in atom. Atomic number is also known as proton number because the charge on the nucleus depends upon the number of protons. Since the electron have negligible mass, the entire mass of the atom is mainly due to proton and neutron only. Since these particles are present in the nucleus, therefore they are collectively called nucleons. As each of these particles has 1 unit mass on the atomic mass scale, therefore the sum of the number of protons and neutrons will be nearly equal to the mass of atom. So the next topic is mass number of an element. So how you are going to calculate the number of protons and number of neutrons. Okay. The mass number of an element is nearly equal to the atomic mass of the element. However, the main difference between the two is the mass number is always a whole number, whereas atomic mass is usually not a whole number. The atomic number and mass number of an element are usually represented all with the symbol of an element as. So I will show you an example how to identify. So X is an element and a symbol of element, okay? And this A is a mass number of an element and the Z is atomic number, okay? Now we will learn about isotopes. The isotopes are such atoms of the same element having same atomic number but different mass number are called isotopes. Examples are protonium, deuterium, tritanium respectively, and ordinary hydrogen is protonium, okay? Isobars are such atoms of different element which have same mass number are called isobars, and of course different atomic numbers are, okay? Like argon 40 is mass number and 18 is atomic number, okay? Isotones are such atoms of different element which contain the same number of neutrons are called isotones. Example, carbon 14 is mass number and 6 is atomic number, okay? Isoelectron are the species containing the same number of electrons are called isoelectronic, and the species of the isoelectronic are atoms or ions. For example, O2 minus, Na plus, Mg2 plus. So the atoms and ions are used in this. Like you can see the upper way minus plus are used. So that's why they are called as isoelectronic.